Hello everyone and welcome back to our channel. So in this video we are going to be talking on measurement. So our topic is area and perimeter of 2D shapes, and you'll find these videos related to measurements under measurement, so the playlist measurement on our channel. So let's get straight into it. We are going to start with the perimeter of 2D shapes. I'm just going to call it P, the perimeter of 2D shapes. So, what is the perimeter of 2D shapes? The perimeter of an enclosed two-dimensional polygon, so D, the 2D, D stands for dimensional, polygon or shape, is the distance around the shape. For a circle, the perimeter is called the circumference. So what we mean here is if we have a shape and it's a 2D, our perimeter in this case, so if we have a shape like this or a polygon like this, and they ask us to determine the perimeter, it means we'll add this side plus that side plus that side plus that side plus that side. So you'll add all these lines that you see in the diagram, so the black, the yellow, red, black, black, yellow, yellow, and green, to get the perimeter. So it's the distance around the polygon. So the distance around meaning only around the polygon but never inside the polygon, so only around. So now let's look at the perimeter, or how we calculate the perimeter of a square. So let's just draw a square for ourselves. So we're going to have square, we're not going to name the points. So let's say, and recapping on what a square is a four-sided shape, and all the sides are equal. So meaning this side is equal to that, is equal to that, is equal to that. And if you haven't learned why we put those marks or those lines on the lines of the shape, it just means they're equal. So looking at this, so let me restart and just recap on that. So if I put one line here which is yellow, and I put another line here, and I put two lines here and two lines here, this means this line here is equal to that line here, and this line here is equal to that line there. We are just labeling them the same. So if you see that two lines have the same or unique way of, like, each line has the same number of lines or the same color, then those lines are equal to each other, equal in length. So if this is 5 meters, this is also going to be 5 centimeters or meters. So let's have a look at a square. So if we say it's a square, then all the sides are equal, meaning this side, this side, this side, this side is equal. So if we name this side S, then we are naming this side also S, S, and S, because all the sides are equal. A square has 4 equal sides. The perimeter is the sum of these equal sides. So the perimeter is the sum of, so let me just highlight that for you. So the sum of, so the perimeter is the sum of these equal sides. So only the surrounding, so the outside, that's what a perimeter is. And according to definition, it's the distance around the polygon. So a square has 4 equal sides. The perimeter is the sum of these equal sides. If one side is S units in length, then the perimeter is then P is equals to, so we add this one, so we're going to add this one, we're going to add this one, we're going to add this one, we're going to add that one. and ignore the color. I'm just trying to prove a point. So we're going to add black. In fact, let me do that so that it's clearer. So I'm going to say S as in S length or S centimeters. And when I come to perimeter, I'm going to do the following. So P is equals to, so I'm going to add this S. So we are adding, it's the sum of the distance around the square. So plus S plus S plus S, and we get what? 1. So if you count 1, 2, 3, 4. Those are 4 S's. So it's 4 times S. And that would be our, so if we simplify it, although it's already simplified, it's just 4S. So that's how you would calculate the perimeter of a 2D shape, in being specific, a square. Let's have a look at how you would calculate the perimeter of a rectangle. So perimeter of a rectangle. So I'm just going to say rect. Okay. So let's draw a rectangle and we are going to name it. We're just going to label it length and breadth. Because we know what a rectangle is, I'm not going to talk much on that. Two sides are equal. Two opposite sides are equal. So this one is equal to that and that one is equal to that one, that side. So if let's label each side, let's say this one is L. So it's L and L for length, and then we're going to call the other side breadth. Because this side is the same as that side, then we're also going to name the side breadth. Now let's calculate the perimeter of a rectangle. So a rectangle has two pairs of opposite sides equal, meaning 2 lengths and 2 breadths. That's why this is equal to that and that is equal to that. The perimeter is the sum of these sides. So if the length is L and the breadth is B, then the perimeter will be P is equals to length. So we are adding this length here plus breadth, right? Plus length plus breadth. And that is, how many lengths do we have? 1, 2. And if you still don't know why we are saying 2 L's, so 2 lengths plus 2 breadths. And that's just algebra. So the L and the L are like terms and B are also like terms. So you can just go and refer back to our algebra videos. Let's move on to the perimeter of triangles. So let's write P of a triangle. So perimeter of a triangle. So we know that a triangle is a 3-sided shape. So the perimeter of a triangle is the sum of the 3 triangles. So let's draw a triangle so that we know what we are working with. So let's try the green triangle. So if the triangle is a scalene, and if you recall, a scalene is a triangle that has all sides different. So if this is A, that's B, and that's C, meaning they are all different, unless we would have said A. That would now be a equilateral triangle. We did a video on that, and you'll find this video in Euclidean geometry playlist on this channel. So let's consider a scalene triangle and the sides A, B, C. Then the perimeter is going to be, so we are only looking at the outside of the shape. So the outside. And so our perimeter, so let's write P for perimeter of the triangle, is going to be A plus B plus C. So that's supposed to be a B plus C. And if the triangle is an isosceles, so this is a scalene triangle, meaning all the sides are different. That's why we have A, B, C. Now let's have a look at perimeter of a triangle that's a isosceles. And if you recall again, this video is on under Euclidean geometry, and it's types of triangles, if I'm guessing correctly. So an isosceles triangle is a triangle that has two sides equal, indicated in that red triangle, small red triangle on top. So if the triangle is an isosceles, then the perimeter is, so let's draw a full or a bigger triangle, a bigger isosceles triangle, and we say this line is equals to that line. That's what the isosceles triangle is. And if those two sides are equal, meaning these two angles are also equal, and that's the definition of isosceles triangle. But in this case, we're not looking at angles or anything like that. We are looking at sides, and we are looking at the distance of the surroundings. So meaning this part of the triangle. So only the outside, and we don't consider the angles. So if the triangle is an isosceles, then the perimeter is, so let's write perimeter so that we can solve the perimeter, and it's going to be P is equals to, so P of triangle is equals to, because it's an isosceles triangle, if we name this A, this is also going to be A because they are equal. And this is now going to be B or another letter. And if we add them, we say A plus B. And if you solve it, it's 2A, and that's algebra again, plus B. Now let's have a look at the perimeter of an equilateral triangle. So P of equilateral triangle, meaning all sides are equal. So let's have a bigger triangle of the equilateral triangle. So it's just that and that. So an equilateral triangle is a triangle that is all sides equal. And if all sides are equal, then all angles are equal. But this is not what we are focusing on, because we are only looking at the outside, and that's the surrounding or the distance around the triangle. So if this side is, let's say, A, and this side is also A, because they're equal, then this side is also A, and all sides are called A centimeters. And let's say if A was 5, then this would be 5, that would be 5, that would also be 5. That's why we name it with the same letter. So let's calculate the perimeter of an equilateral triangle. So it's just going to be P is equals to A plus A plus A, and those are 3A, so we're going to say 3A. So when we calculate the perimeter of a triangle, it all depends on the triangle. And so we're going to have exercises on that, but it's not going to be complex. You don't really need to know that the triangle is a scaling, because most of the times we get values for our A's and our B's, and it's easier to calculate. You just add all the sides together. Now let's have a look at the last perimeter we get of a 2D shape, and in this case is the circumference of a circle. But before, so let's just write perimeter of circle. Before we discuss the circumference of a circle, let's revise some circle terminology. So let's draw a circle for ourselves, because we need to recap on what so we are going to have a circle, and we are going to label it. So we have a circle, and we are going to name the center O. O. So the part I'm going to highlight in yellow, okay, let's say blue, let's say red. The part I'm highlighting with yellow, that's the surrounding of the circle, right? That's the distance around the circle, and that's what we call the perimeter. But when it comes to circles, that's no longer the perimeter, it's called the circumference. So let's label it and say this is now the C, and we can say circumference. And we can write it, we can make this easier for us by just saying So that's the circumference, and we are going to have the radius. And if you recall, the radius is the distance from the center to the circumference, and the center, we said it's O, right? So if we are saying the distance, then it's from O, so from point O to any point of the circumference, which is the surrounding of the circle. That's called the radius. So this red line here is a radius. This is a radius. This is also a radius. This is also a radius. So yes, a radius is a line that's from the center of the circle to any point of the circumference. And we want to label that R. And on the side, we're just going to say R is for radius. Then another thing we have is the diameter. The diameter is twice the radius. Now let me show you why it's twice the radius. Because the diameter, the radius is from, can you see it's half of the circle, from the middle point of the circle to the point of the circumference. But the diameter is from one point of the circumference to the other point of the circumference. Note, the one I'm going to draw now, which is this one, is not a diameter. A diameter has to pass through the center of the circle, in a way dividing it into half. So in this case, we are going to do the following. And whenever you draw a diameter, you'll also see that you're really halving the circle. So you are dividing the circle into one. And this is our one part. The other part would be this side of the circle. So you're dividing the circle into half, and that's a diameter. So a diameter, for it to be called a radius or diameter, there has to be a center. After that, the radius is, so looking at this, let's draw the radius on top of our, so our radius will still be something like that. So from the center of the circle to the circumference, meaning the radius is half the diameter. The red line is half the yellow line, because the diameter is from one circumference to another while touching the middle of the circle. And that's the summary of a circle's terminology. So now let's have a look at a diameter. So a diameter is a line passing through the line and joining 2 points on the circle. It divides the circle into 2 semicircles, as you can see and as I have showed you guys. A radius is a line from the center to a point of the circle, and I've already shown you that. Now the perimeter of a circle is called the circumference, and I've already showed you that. That's just revision. The length of the circumference can be measured by cutting the circle at a point and then straightening it out. So if I were to cut the circle here, then our circle would look something like, sorry about that. So our circle would look something like that. And if you were to straighten the circle, it would look something like, so if you were to put this point there and that point there, it would look something like that, which is a straight line. And that's why we say, and that straight line makes, so if you fold this straight line, so this green straight line, it will form a circle. That's why we say the circumference is the perimeter, because it's still the distance around the circle. So how do you calculate the perimeter of a circle? So the perimeter of a circle, the length of the circumference is calculated, see, because we said the circle does not, it has a perimeter, but we call the perimeter circumference. So we're going to say circumference of circle is calculated by saying C is equals to 2 pi radius. And I'm pretty sure you have learned what pi means. Where R represents, so this R here, so let's break it down. This is the circumference, right? This 2 represents a constant. Then this R here represents the radius. So this represents the radius of the circle. And so if you're given a circle and you are given any of these, you can plug them in and calculate the missing value or the unknown. So pi is a name given to the ratio of circumference of a circle to its diameter. That means for any circle, no matter how big or small, you can divide the circumference by the diameter and always get exactly the same number, which is, so pi is 3.141592, which is a rational number, and it goes on and on, so it does not stop there. So we are going to calculate the perimeter for this shape or polygon. So we are going to start off by filling in the missing lengths and then add up all the lengths to get the perimeter. So looking at this, let's trace it using the highlighter. So we're going to start at this corner, we're going to go up like that. So 1, let me just restart, I think it's a bit thick. So that's our highlighter, and we are going to do the following. So we're going to go up 1. So I'm trying to show you that we have missing lengths. So we're going to start here with 4 centimeters, 3 centimeters, 1 centimeters. We don't have anything, we don't have anything, we don't have anything, we don't have anything, we don't have anything. 3 centimeters and then 6 centimeters. So the question you should ask yourself is, how do you get the length of each of these lines on that green path that I've just highlighted for us? And referring back to the previous slides, we said if 2 lines have the same small markings as shown here, can you see that's 1 line on that line and there's 1 line on the other line? So there's yellow lines on, there's 1 yellow line on each red line, meaning they are equal to each other. So if this is 1 centimeter, this is also 1 centimeter. So let's use a different color. So this is also 1 centimeter, this is 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, because of the yellow marking that it has. So now that we have, let's check again if we have enough lengths. So we go from 4 centimeters, 3 centimeters, then 1 centimeter, and we saw that we solved this one and it is 1 centimeter. So 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 3 centimeters, and 6 centimeters. And we can see that there is no missing length. Now we say the perimeter is the area around the project and around the polygon and not inside. So now let's write down what our perimeter is by adding all the lengths. So we have P is equals to, we're going to start here 4. You can start anywhere as long as you add up all the sides. So we've done this side 4 plus, we've done that side 3 plus 1 plus 1. So plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 3 plus 6. and this is the 6 we're talking about. And we get that our answer is, so I'm going to write it right there, and our answer is, so it's 4 plus 3, which is 7, plus 1, 8, 9, 10, 11, 12, 13, 14, 14, 17, 23. So our answer is, let me count again, 4, 7, 8, 9, 10, 11, 12, 13, or 13 plus 3, 16, 16 plus 6, which is 22. So 22 centimeters. And that's our answer. And you must always remember to never leave out your units. Now let's move on to another question like this, and then we have one that involves a circle. And then we'll move on to area of our polygons. So in this case, we're going to draw a shape like that. My drawing skills are not on point, you guys. We actually don't have that line there. So it's something like this. And then you just go down. Yeah, so we have a shape like this, and we are required to calculate, okay, so we're required to calculate the perimeter once again. And so let's fill in what we have. So all of these are in centimeters, so we have 6 centimeters right there. We have 2 centimeters right there, and that's all we are given. And then they labeled the graph, so, or the polygon G A F B C D and E. So the given shape is made up of, so when you look at this, you want to break it up. So we can calculate, so you will tell yourself we can calculate, because you can't calculate the perimeter without the lengths, right? So you look at your polygon and you find out which lengths are missing. So in this case, it will be this length we're given, which is 6. Then we have GA does not have a length, AB does not have a length, BC does not have a length, and then we have a 2 here for CD, but EDE does not have a length, and EF does not have a length. So we have so many unknowns that we can't even start by just adding, because there's nothing to add. So we need to find out what our lengths are. And so what we do is we analyze this polygon and we try and figure out how we can get those lengths. So the easiest way is to break this polygon into different shapes, and then you find the perimeters for each shape, and then you move on. Or you use the fact that you have those shapes, and then you fill in the different values, and then you move on. So whatever is that you prefer when given the question. So given this shape is made up of the rectangle, which is here, a square, and an equilateral triangle. So they tell us that this is an equilateral triangle, and if you haven't learned the types of triangles, because they are needed in measurement, then please go and visit the measurement video, types of triangles, and that's the name of the video. And you just recap on the kinds of triangles we get, and I think, if I recall correctly, we get 3 types of triangles. No, we don't. We get more than 3. Sorry about that. Now we are required to calculate, and we're given that this, so let's label it, not label but mark our meaning this line here is equals to that line is equals to that line, because it's an equilateral triangle. So now let's find our missing. We're going to use red so that we can see which ones we added. So let's look at which one is easiest. So we are told that this is a square, so let's put an S for square, triangle, equilateral triangle. Okay, we already marked that one, so we don't need to put that. And then we are given a rectangle, so we put an R for that. Now let's look at our square. A square, we all know that a square has equal sides. So if this is 6 centimeters, then this is also 6 centimeters, 6 centimeters, 6 centimeters. So all the sides are 6 centimeters. So we fill that in 6, 6, and that's also a 6 right there. Then we are told that the triangle is an equilateral triangle, meaning if this side here is 6, then this side here is also 6, and this side is also 6. So this is also 6, and that's also 6. Then we are told that this part here is a rectangle, and you know that a rectangle, this line is equal to that line, and that line is equal to that line. So if this is 6, this is also 6, and if this is 2, this is 2. Now you can see that we have figured out all the missing lengths of our polygon. Now let us trace back to see if we've missed anything. So 1, 2, 3, yeah, 6, 6, 6, 6, 2, 6, 2, and we just got back to where we started, meaning we have the lengths. So now let us solve. So we're going to say perimeter of our polygon is equals to, then we're going to start here by 6. So we're going to say 6 plus 6 plus 6 plus 6 plus this 2 here plus the 6 plus the 2. And if you add them all together, that's 6 plus 6, which is 12. So let's count in 6. So 6, 12, 18, 24. Then we have another 6 here, so that makes it 30. Then we can say 30. So our answer in this case is 30 plus 2 is 32, plus 2 is 34. So our answer in this question is 34. Let me use another color. Let's choose black. So 34 centimeters. And that is our answer for this question. Let's have a look at a perimeter question that involves, or circumference question, because we are talking about the circle. So let's draw a circle real quick. So we are given a circle and we have a center, and they tell us that we have a diameter. So a diameter is a line that passes through the center. Even if, let me show you, even if the diameter looks something like this, as long as it's from one point of the circumference to the other point of the circumference, but in a straight line, then that's a something like that. Then this is a diameter. So it does not matter where your diameter is facing, but this is the ideal thing when you're talking about diameter. So let's just make it different so that we get used to how they can trick us. And so let's say this is a diameter. Why is it a diameter? Because it touches the circle at this point and at that point of the circumference, or the outside of the circle, and it passes through the center of the circle. So calculate. So we're given that the diameter is 10 centimeters. So let's just fill that in before we continue and read our question. So calculate the circumference of the circle with a diameter of 10 centimeters. Round off your answers to 2 decimal places. Now the thing with measurement is it's all about formulas that we have to recall. And if you recall from our previous video, we introduced this formula for circumference, which is C is equals to 2 pi radius, and radius is half the diameter because radius is only from there to there, right? So that would be in line. So let's choose a bright color so that you can see what we're doing. So 2 pi, and the radius is half the diameter. Why? Because of what I've just shown you. So radius is going to be 5. And if you use your calculator, you get 10 pi. So we're going to just simplify it a bit before we get to the final answer. So this 2 here plus that 5 times that 5 gives you 10, because 2 times 5 is 10, and 10 pi centimeters, right? And our answer is going to be, if you type it in your calculator, and there's this pi sign is on your calculator as it is, and it can just differ by how it's written. They can just, you know, make it curly on all, but it's the same thing. So 10 pi, if you type that 10 pi in your calculator, you'll get 31.42 centimeters. And that's how you do this question. Let's have a look at another question. Maybe let's have 2 more, because we need to understand this. We need to understand how to calculate perimeter or circumference of a circle when, you know, when they try to trick us. So let's go ahead and do that. So in this question, we are given half a circle. So we are given half a circle. Okay, I think this one is better off if we draw it ourselves. So we're given half a circle. If it's half the circle, that means this line here is the diameter, because the diameter halves the circle into 2. And we are given that this is the center. So this is the question. Calculate the circumference of the semicircle with the radius of 12 meters. So this is the radius 12 meters, meaning if it's a diameter, then we have, so if it's this, then we have 24 meters, because the diameter is twice the radius. So now we are told that we need to calculate the circumference of the semicircle, right? Our formula is this, 2 pi radius. But as we all know, this formula is for a full circle. So what happens when we halve the circle? Then we halve the circumference. So we say half times the 2 pi radius. Let me just recap on why we did that again. Because this formula here, if you recall, let me just go back to the slide. We say that that's the circumference of a circle, a full circle. So a circle that starts from one point and ends the other. You know how a circle looks like. And in this case, you can see that we're given half a circle. Now they want us to find the circumference. So that's the circumference formula in red, circled in red. So if you're looking for half the circle, that's half the circumference. So that's half C. And if it's half C, then it's half 2 pi radius. And then we fill it, we just solve for the circumference. So it's going to be half times 2 pi. Radius is going to be 12. And our answer would be 12 pi, which is equals to 37.7 meters. So we move on to the next question, and I know I might have said that was the last one, but I just want us to understand the concepts even better. So we're going to look at the next example, which is also a semicircle. So we're given that, and okay, let me try my best. Pretend it joins, you guys. Yep, so that's our semicircle, and we're given that the radius is 5 millimeters. So we are 5 millimeters, okay? 5 millimeters. So calculate the perimeter of the semicircle, circular shape. Calculate the perimeter of the semicircular shape with a radius of 5 millimeters. Round off your answer to 2 decimal places. So we're required to find the perimeter of, so the perimeter is a part of the perimeter of the diameter is a part of the perimeter of the semicircle. So let's go back to what's the difference between this one and this one. In this one, we were not given this. So we were calculating this part of, so we're calculating this part of the circle, which is the semicircle, because the full circle would go like that, right? Now we are given this, so they are telling us that we need to use that part. And so the diameter is a part of the perimeter because it's this plus that makes up the polygon or the shape. The diameter is twice the radius, right? So our diameter in this case would be 10 millimeters because our radius is 5 millimeters. So this is, let's do that, and that's going to be 10 millimeters. Perimeter of the shape is then equals to a half. So we are calculating that first, right? We're calculating this part first. And then after that, we just add the 10 here. So it's going to be half 2 pi radius. Why? Because we are looking at half of the semicircle, right? And that's going to be half 2 pi, and our radius is 5 because we're given in the question. And we get that our circumference of the semicircle is then 5 pi. So if you were to calculate this, you get 5 pi millimeters. Then so the total, so P total is equals to circumference of the semicircle plus the diameter, which is 5 pi plus, not times, so 5 pi plus 10, and you get that your answer, if you type that in your calculator, you'll get 25 point. Let me write the answer there, and it's going to be 25.71 millimeters, and that's our answer. So this is the answer in this question. So the answer is 25.71. So what's the difference? Is because this side we're required to calculate this, but here we're only given the semicircle, and this was supposed to be a dotted line. Let's have a look at the last question. Yeah, the last question. So we are, let me draw the sketch. So we have that. So we have a small triangle right there. Yes, and this is supposed to be dotted. So let's label them. So that's A, B, C, D. And this line, the dotted line, is 8 centimeters long, and that's a right angle. and that's 6. So they're asking us to, let's read the question. So the diagram represents a shape made up of a quarter circle, this is the quarter circle, okay, and a right angled triangle, which is triangle BCD. So triangle BCD. If you can notice, I am pointing them with the red marker. And then so the question is, show that the perimeter of the shape is given by P. So we have to show that it's given by P is equals to 4 pi plus 24 units. So let's start off by looking at the semicircle, and then we get to the triangle, the right angle triangle. So what we do is we find the circumference of the quarter circle. So the circumference of the quarter circle is equals to, so we say a quarter 2 pi radius, right? Because it's a quarter of, this is the full circle, right? So then it's going to be a quarter, and our radius is 8, because remember this is the center of the circle, and we said if a line starts from here and goes there, or a line goes from there, from the center to any point of the circumference is a radius. So this is also a radius, which is 8. So it's 2 pi 8, and we get that's 4 pi. So that's 4 pi. The radius AB is a solid line and therefore must be included. So this should also be included because it's a solid line and it makes up the shape that goes like that. So we're trying to calculate the perimeter of that shape right there. So for now we've calculated the circumference of the quarter circle. Now let's get on to calculating the perimeter of the right angle triangle. So AB is 8 units because BD is also 8 units. So this is 8 units. This is 6. This is. So we need to calculate that part here. Because we need this line, we need this line, we need this line, and we've already gotten that part there. So how do we get DC? Because it's a right angle triangle, we are allowed to use Pythagoras theorem. So let's just say, because we don't have space and I want us to work while seeing the diagram or shape, so I'm going to just say C4 quarter. So circumference of a quarter circle is equals to 4 pi, and I'm going to erase this part because we need the space. So I'm going to use black. So how do we get DC? We use Pythagoras theorem, and this part here is the hypotenuse. So we can just say h squared is equals to, this is C by the way, so it's equals to 6 squared plus 8 squared. And that's what the Pythagoras theorem states. So you just write Pyth right there. Sorry, Pythagoras for, so that's, yeah, that's why we say Pythagoras, because we are using the theorem of Pythagoras, and you need to state your reasons. So it's going to be 6 squared is 36, 8 squared is 64, and if you add them together you get 100. So we want h, not h squared, so you square the 100, because here there's h squared and here there's h squared. And if you square 100, square root of 100 is 10, and that's 10 units. So this part here is 10 units. Now the perimeter of the shape you calculate it by doing the following. Sorry about that, so we need to erase this once again. So we just calculated and we saw that this H here is 10 units. Now we just have to compile our perimeter because we already have this part. So let me highlight it. We already have this part, we have this part, we have this part, and we have that part. So it's going to be, so the answer is going to be the 4 pi that we calculated at first, which is this part of the circle, and then plus 8, which is that part. So plus 8, plus 6, which is this part, plus 10, which is that part. And we get that our answer is 4 pi. 8 plus 6 is 14. 14 plus 10 is 24. And we've just proven what they wanted us to prove. So we've just proven that the perimeter of this shape is, let me write it clear. So perimeter total is equals to 4 pi plus 24 centimeters. And so that is it for this video. Thank you so much for watching. See you in our next video as we discuss area of 2D shapes. Bye.